A filter in digital audio is a way of emphasizing or eliminating some frequencies from a signal. So when we talk about filters in digital audio, there's some basic types of filters. There's something called a high pass filter, low pass filter, band pass filter, and band reject filter. These can be abbreviated as follows. So we have a high pass filter, HPF, LPF for low pass filter, BPF for band pass filter, and BRF for band reject filter. I'm in Logic right now. I'm just going to play an audio file. And you'll notice that there are just certain frequencies that are present over time. So what we have here is, this is a frequency domain graph where frequencies go from low to high. So you can see that there's a peak here very close to 300 hertz. And there's another peak kind of close down here to 200 hertz. There's another peak right here between 400 and 500 hertz. And we can also see the relative strength and weaknesses of the different harmonics that are present in the signal over time. So what we can do with a filter is, in this case, I've activated a filter, and now what's going to happen is, this is the equivalent of a high pass filter. High frequencies will be allowed to pass, and as I pull this across as the cutoff frequency, that's what this is right here, my cutoff frequency will point at where I will cut frequencies, and then there's this sort of line that goes down here, and this is referred to as Q, and there's some different terms for it as well, but it's often referred to as Q or resonance. So you can see that anything that's in this darker red color will get removed from the signal, and all these signals over here will be allowed through. So if I bring this up really, really high here, and if I increase the Q or resonance, let's see if I can do this, there we go, then you can see it becomes a sharper cut to the frequencies. So if I, for instance, played it right now, we'd only get these very few, very, very high frequencies. So let's hear what this sounds like as I draw it across. And so that would be a high pass filter, allowing high frequencies to pass, and then we cut low frequencies. And obviously a low pass filter is the opposite of that, where I would cut high frequencies and allow only low frequencies to pass through. Here's what that would sound like. So here's a picture of sound. And so just to sort of show how the different filters can work, if I can imagine having a high pass filter, I'm letting high frequencies pass, and then at some point I would cut lower frequencies. So these signals would be allowed to pass, and anything over here would be cut. And a low pass filter would look like this, where this area would be allowed to pass, this signal would be cut. So this would be a low pass filter. Then a band pass filter actually would just be a narrow band of sound that this is allowed to pass, and everything else is then rejected. And then finally we have a band reject filter, which would only reject certain parts. So maybe only this area in here would be rejected, and everything else would be allowed to pass. And so as we're adjusting the cutoff frequency, that moves this point right here up or down the frequency spectrum. And then our Q will be how deep or how or how sharp or gradual we're cutting off their frequency. So if I did a band reject filter and I had a very open Q, it might look something like this, where these, this is a band reject. So all of this is being rejected and only this is being allowed to pass. Or if I had a very sharp Q, it might look something like this, where now just this very narrow band is rejected and everything else is allowed to pass. And we can also have Q on any kind of filter, including, let's say, a high pass filter, where this would be a very gradual Q, and this would be a really sharp Q. So our cutoff frequency would probably be here somewhere, and our Q would be this curve here. So the combination of Q or resonance and the cutoff frequency will really affect how we can use a filter. There are lots of different ways that you can apply a filter to MIDI and audio tracks. To add a filter to any track, all we need to do is go over to our audio effects, and there are a couple different options for filters. There's actually a filter delay here. So this is a combination of delay line that's also filtered. If you just want to use a filter, you can just use this auto filter. And there's also a few EQ options here, which also give you some different aspects of being able to filter different parts of audio and MIDI tracks. So again, all I have to do is, if I just want to use a preset, I just drag this into a track, and now it'll appear as a device in my device lists here. So here's my instrument, this FM Piano 4 filtered. And now I'm actually adding a filter. This object right here is the actual filter. Let me delete that. If I want to grab a preset, all I have to do is grab one of these, and sort of these are the same, just now with a preset setting there. So I have two tracks here. This track that actually just has the piano sound, and this other track actually has the filter, so we can hear the difference between these two. So I'll play the first track. So this is unfiltered, and it's just a very simple little MIDI track. And notice just how static and stagnant this is. So that's in contrast to now this second track, which uses a filter sweep. So you can see just how much more to life it brings something as simple as just a repetitive ostinato that repeats over and over again. Now by adding some filtering through here that changes over time, it really brings the clip to life. The same could be said for rhythm and beats. So this particular track is an audio track. It could also be MIDI though, again. It could be a MIDI beat pattern. This happens to be audio. So here it is with no effects, just the audio sample. Okay, so, and now we're going to go to the second track. And so here is the actual filter. So when I play this, you can watch what happens to the filter down here. So again, something that looks pretty static on the page, pretty straightforward when I just play it on its own. Can really come to life. And what's really cool is if I actually put both of these together. So let me just copy both clips. So now we can listen to both together. I'm going to bring the level of these both down a little bit, and I'm going to have the filtered one just higher, just a little bit, so we can hear a little bit more of the filtered track. So lots of different ways that we can use filters on sounds, and particularly when you add automation and have the filter change over time, it really can make your music much more dynamic and interesting.